All right, so we're looking at some more factoring the trinomial. So with number 18, let's go ahead and write it out to the side here. So we have some more room to work with. Minus 35b squared. All right, so again, let's ask ourselves those two questions that we should be asking with every single factoring problem. Is there a GCF? I don't see one. All right, so question number 2, how many terms are there in this expression? Well, 1, 2, 3, so there are 3 terms, right? Trinomial. Excuse me. So that tells us, because we have 3 terms, we can either use the scissors method or the AC method or trial and error. But in this case, we really don't have to use either of those 3 methods because the coefficient in front of our squared term is 1. And when the coefficient in front of your squared term is 1, you are really dealing with a more simplified factoring problem. So let's go ahead and, just like before, because this is a trinomial, we're going to create a set of empty parentheses. And since our squared term here at the start is an a, let's go ahead and put an a. And you'll notice here that now we're working with 2 variables, aren't we? An a and a b. So we have a squared term at the beginning and a squared term at the end. So when you have this situation occur, well, we are always going to put whatever letter is at the beginning, that first squared, at the beginning of our set of parentheses. Whatever letter or variable is being squared at the end of your original expression, we're going to put at the end of our set of parentheses. All right, so a was at the beginning, so a is at the beginning of our sets of parentheses. B was at the end, so B is at the end. And now we'll go ahead and treat this just like we were doing with 16 and 17. So we're looking for factors of 35 that subtract to give us -2. All right, well, let's go ahead and let's see if we can list the factors of 35. Well, we have 1 and 35. Well, 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 works though, right? 5 and 7. 6 doesn't work, 7 doesn't work, 8 doesn't work. All right, so I think this might be it. So let's go ahead and take a look. Can we, in some combination, subtract a 1 and a 35 to get to a -2? No, I don't think so. Can we, in some combination, subtract a 5 and a 7 to get -2? Well, yeah, we can, right? We can have a +5 minus 7, and that will give us a -2, right? So since our 5 is positive, let's go ahead and do +5. And since our 7 is negative, let's go ahead and do -7. And now we have our factors, don't we? And again, if on a test you weren't sure about this, you can go ahead and FOIL this out and see what you get. A times A gives us A squared. A times -7B gives us -7AB. 5B times A gives us +5AB. And then 5B times -7B gives us -35B squared. Let's go ahead and combine our like terms here. So we get A squared minus 2AB minus 35B squared. Does this thing match the original expression we started with? Yep, it sure does. So we know that we factored this trinomial correctly. All right, let's take a look here at number 19. And we have 2x squared minus 12x plus 16. All right, so what is that first question we always ask ourselves when we're factoring? Is there a GCF? And in this case, there actually is a GCF, isn't there? We can go ahead and factor out a 2 from each of these. And so when we take a 2 out, we're left with just x squared minus 6x plus 8, right? Because 2 times x squared is 2x squared. 2 times -6x is -12x. And 2 times +8 is +16. All right, so now let's go ahead and factor this trinomial just like we've been doing with the previous few questions we've been working with. So we have our 2 out front, that's what we factored out. And since we're working with a trinomial, we know this is going to factor into 2 binomials. We're working with an x, so let's go ahead and fill that x in at the start of each set of parentheses. And now we're looking for factors of 8 that add to give us -6. So let's go ahead and list the factors of 8. Well, we have 1 and 8, 2 and 4, and that's it. Well, can we in some combination add a 1 and an 8 together to get a -6? No, I don't think so. Can we in some combination add a 2 and a 4 together to get a -6? Yeah, I think we can, right? -2 plus -4 gives us -6, doesn't it? All right, so -2, -2, -4, -4. And now we can go ahead and double check ourselves. Let's see, -2 plus -4, yes, gives us -6. -2 times -8 does give us -2 times -4 does in fact give us a +8. And so we can go ahead and call it a day there. If you wanted to double check and FOIL these factors out, what you could do is you could either FOIL these 2 binomials together, whatever that gives you, then go ahead and distribute a 2 through it, or you could take your 2, multiply it by this first set of parentheses, whatever that gives you, then distribute with this x minus 4, or you could start with the 2 and multiply it by the x minus 4 here, whatever that gives you, then multiply it by x minus 2 again. Doesn't matter what order you multiply in, you will end up with the same result. All right, if it were me taking this test, I would probably go ahead and just FOIL these 2 binomials together, and then whatever that result is, then distribute the 2 through. So let's go ahead and do that. So we have x times x, well, that's going to give us an x squared. X times -4 is going to give us -4x. -2 times x will give us -2x. -2 times -4 will give us a +8. Let's go ahead and combine like terms. So we get x squared minus 6x plus 8. All right, and then we're going to take that 2 that was on the outside, and now we're going to distribute it through and see what we get. So we have 2 times x squared, well, that gives us 2x squared. 2 times -6x gives us -12x, and 2 times 8 gives us +16, that's a plus. And now does this trinomial match the original trinomial we started with? Yes, it does. So we know that our factoring was correct here. All right, this was 18 and 19. I'll see you at the next set of questions. This is Joe Brownlee with Palm Beach State. Thanks for watching.